name of the Father, and of the Son, and of the Holy Spirit. Amen. Okay, so we will be having a short review of all of the things, concepts, principles that you have already learned before in your pharmacognosy class. So we'll just have a quick overview of all of these important or pertinent topics. Okay, so this would be the outline or flow of our discussion for this meeting up to the next meeting by next week. Okay, so the first part would talk about the history and also basic concepts in pharmacognosy. On the latter parts, we will have the different concepts of the different plant compounds or metabolites found on plants. Okay, so in the introduction or for the introduction, we defined before the field or the practice of pharmacognosy. So basically, this core subject deals with any aspects of the compounds that are found on plants, okay, and other natural sources. Okay, so these natural sources, plants or animals, are termed as natural products. Kung ano yung makukuha mo out of that plant organism or an animal organism, these are termed as natural products. Again, kung
recording
ano yung
in progress
mo or ma-acquire mo from plants and animal organisms. So these are called natural products. So basically, pharmacognosy deals with the physical, chemical, biochemical, and biological properties of substances or compounds found of these natural sources, in which this could be utilized in medicine. Okay? So pharmacognosy comes from two Greek words. Pharmakon, which means drug. Gignosko means to acquire knowledge of. Okay? Pharmakon, which means drug. Gignosko means to acquire knowledge of. So now let's move to the history. Okay? So it was Johann Adam Schmid who utilized the term pharmacognosy in 1811. Okay? And in 1815, Sadler utilized the term pharmacognosy in his work entitled Analecta Pharmacognostica. Okay? So Schmid's work where he used or coiled the term pharmacognosy is the title of his work is called Liber de Materia Medica. While for Sadler in 1815, his work is called Analecta Pharmacognostica. Okay? So aside from Schmid and Sadler, there were already people who existed before them that made works or books that would talk about utilization of plants and animals to be used as medicinal agents. Okay? So we have De Materia Medica by Dioscorides. And also one of the earlier discoveries of use of plants as medicinal agents were recorded in papyrus ebers. Okay? So Papyrus Ebers was discovered by George Ebers. So this Papyrus Ebers originated in Egypt. So there were already 100 prescriptions written in Papyrus Ebers. Okay? Other prominent people who has contributions in uses of plants as medicinal agents was Flockiger and Galen. Okay, Galen, who formulated preparations of cold creams, or what we know as the Galenicals. Okay, and also Galen has a work on acquiring drugs or drug products or drug compounds from plants and animal sources. Okay, so how does these crude drugs coming from plants being processed? Okay, we have these different steps. We have collection, harvesting, drying, curing, garbling, packaging, and storage. Okay? Collection and harvesting must be done early in the morning, at least as much as possible before 8 a.m. Because by that time, mababa pa yung degree or levels of the wavelengths coming from the sunlight, okay? Because this could disrupt compounds found on plants, okay? Then drying, there are two general ways to dry. We have the air drying and the drying using an equipment or using an oven, okay? But the most ideal way to dry, lalo na pag ang plant sample mo is leaves, seeds, or the roots, you could utilize, or even the bark, you could utilize air drying. So air drying usually would last for 17 to 14 days. Okay? Next is curing. Curing is a modified process of drying. Then after drying, you will be acquiring the dried plant samples, literally the dried plant samples. Ano yung kailangan gawin mo sa dried plant samples? You will be conducting garbling process. Okay, so the garbling process is a process on removing extraneous matter from that dried plant samples. Okay, because this extraneous matter would somewhat cause contamination, or it could also destroy the dried plant materials through contamination. Okay? Then after garbling, packaging, and storage as well. Okay? Then right after this processes, you could proceed to a more thorough processing of crude drugs coming from plants, like your extraction process. Okay? So all of these are the different steps or preparations in doing or making or acquiring crude drugs coming from plants or natural sources. For the plant extraction process, we have two general processes. We have maceration and percolation. Okay? If you could still remember our discussion before, maceration and percolation has the same principle. Okay? The principle of soaking. Soaking the plant material, which will be your solute, with a suitable solvents. Okay? Common solvents utilized for plant extraction process includes alcohols. The alcohols are used for crude extraction process. So what would be the difference between the two, the maceration and percolation? One would be the medium of the extraction process. Okay? So maceration usually uses a medium, glassware, mediums such as glasswares. Okay? Like beakers or earthenware flasks. So doon ilalagay yung plant material with a suitable solvent for extraction. While for percolation, it uses a specialized apparatus called the percolator. What is the advantage of using percolator? The flow of the solvent during filtration process would be on a one direction from top to bottom. So top to bottom ang flow ng solvent once you will be collecting the liquid extract. Hindi tulad sa maceration that you need to agitate the mixture so the mixture will be disturbed. Okay, so there is no neutrality of the reactions that would occur. So madi-disturb mo yung mixture, okay? Because it will be agitated once you collect the liquid extract. For percolation, one direction lang yung flow niya. Ano yung mas advantage niya? Okay? Due to that one direction flow, you will be collecting more liquid extract as compared with maceration. But it is not that significant. Okay? Yun lang yung isa sa mga difference nila. The flow of the solvent once the liquid extract will be collected, and also the medium that will be used for extraction process. Okay, so after you have that extract, you'll conduct phytochemical screening. So phytochemical screening is a process or methods that is used to characterize as well as identify what compounds are present to your plant extract or to your plant samples. So there would be two types of tests utilized in phytochemical screening. We have qualitative tests and quantitative tests. Okay? So qualitative tests usually utilizes test tube methods, test tube colorimetric methods, while quantitative tests, because you're after for the amount or concentration of present to your sample. Okay, so for quantitative tests, you will be using chromatographic procedures or even complex type of equipments, complex type of procedures that utilizes equipments in order to have or acquire the amount or concentration of that compounds present to your sample. Okay, so what are the two general types or classes of plant compounds? So we have primary and secondary metabolites. Okay, again, the two general classes or types of plant compounds includes primary and secondary metabolites. Okay, so how would we differentiate primary metabolites from secondary metabolites? Okay, so primary metabolites are those compounds that are essential or pertinent to the physiological processes that occurs in plants. Okay, so these compounds or metabolites are needed for the growth and survival of the plant. Again, these compounds are needed for the growth and survival of this plant organisms. Okay, or they are basically needed by the plants. While on the other hand, secondary metabolites are plant compounds that are called accessory compounds in which wala siya masyadong utilization sa plant. Okay? So they are less pertinent to the physiological processes that occurs in plants. Excuse me. Okay, so these are less pertinent to the plants, but these plants are being utilized, these plant compounds are being utilized by other organisms like animals, in which these plant compounds are, or the secondary metabolites or plant compounds are used for any important utilizations as medicinal agents or as agents that could help in the daily needs of other organisms. Okay? So that would be the difference between these two classes of plant compounds. So examples of primary metabolites, those that are used by the plants for their growth and survival, which includes the biological macromolecules like proteins, carbohydrates, enzymes, nucleic acids, hormones, etc. Okay? Well, on the other hand, secondary metabolites. These are those compounds that are exclusively produced by plants and plant-like organisms. Ito yung mga accessory organs, accessory compounds that are being produced by plants, which are beneficial to other organisms, not on plants. Okay? So this includes the polyphenolic compounds, flavonoids, glycosides, alkaloids, etc. Okay, so all of this would fall under the classification of secondary metabolites. Excuse me. Let's get back. I was away from the computer moments ago. Okay, so let's get back. So these are the different physiological processes that are involved in producing plant compounds, primary and secondary metabolites. Okay, everything starts with photosynthesis, in which the products of photosynthetic reactions like glucose are utilized in order to be a precursor for other metabolic pathways that would occur, like glycolysis, shikimic acid pathway. So the shikimic acid pathway usually produces aromatic amino acids, okay, like phenylalanine, tryptophan, and tyrosine. Okay, so phenylalanine is utilized in order to produce or as a precursor compound in the metabolic pathway that produces polyphenolic compounds and other plant-related compounds. The acetate mevalonate pathway are utilized to make plant sterols and also plant terpenes. Okay, terpenes, which are active components or main components of essential oils, and also the acetate malonate pathway, which are utilized to make fatty acids out from those lipid intermediates that are produced along in the acetate malonate pathway. So these fatty acids are the components of some plant products like fix oils. Okay? So all of this have roles in making plant compounds. Okay? Alkaloids and some antibiotics coming from plants came, as well as proteins, came from amino acids that are produced from transamination reactions. Okay? So, common important building blocks or intermediates that are used to produce plant metabolites would include the following. Okay, we have mevalonate. We have also shikimic acid. And also acetyl coenzyme A. Okay? So all of this are, as well as deoxycellulose. Okay, so all of this are the important intermediates for the different metabolic pathways. Okay, so acetyl-CoA is utilized both in the acetate mevalonate pathway and acetate malonate pathway. Okay, so now let's move on to the different plant compounds. Okay, we have the primary metabolites. So first on the list are the hydrocarbons. Okay, so hydrocarbons would contain, coming from plants, would contain basically carbon and hydrogen atoms. Okay, so these are odd number long chain alkanes with a range of 25 to 35 number of carbon atoms. Usually, these compounds are formed from decarboxylation process. Next, lipids. Lipids are esters of long-chain fatty acids. These are non-polymerizable compounds. Okay? And also fatty acid products like andesylenic acid and sodium morowate. So the different classes of lipids would include fixed oils, fats, waxes, and prostaglandins. Okay? Fixed oils are plant products that would contain fatty acids. So, fixed oils are described to be viscous in liquid form. So, we now have the different examples of fixed oils. Okay, we have castor oil coming from the plant Ricinus communis. Okay, so, ginagamit si castor oil as a stimulant cathartic. But there are other applications of castor oil. It has an antimicrobial property once it is used topically. Next is olive oil, which have a wide utilization in culinary, okay, for culinary purposes. Before, there are soaps that would contain olive oil. Olive oil comes from the plant Olea europaea, and it is one of the largest produced oils in the world. Fifth in the largest oils being produced in the world. Next, we have peanut oil that is also utilized for injections as a vehicle for injections. So it is a non-drying oil coming from Arachis hypogea. We have also sesame oil, okay, coming from the seeds of Sesamum indicum. So aside from the fatty acid content, it contains sesamol. So ginagamit din si sesame oil as a vehicle. We have corn oil. Corn oil is also used as a vehicle for injectable products. Okay? So corn oil comes from the cobs of Zea mays. Next is cottonseed oil. Cottonseed oil comes from Gossypium hirsutum. So ginagamit din ito siya as a vehicle or as a diluent. We have almond oil. Almond oil has less pharmaceutical value nowadays, but it is widely used for culinary purposes. It comes from Prunus amygdalus. Next is persic oil, coming from Prunus armeniaca and Prunus persiaca. Next is coconut oil, coming from the endosperm of Coccus nucifera. Okay? So hindi to siya ginagamit as a diluent for injectable products because of its high acid value. So the main fatty acid content of coconut oil is lauric acid. Okay? It contains high amounts of lauric acid. That the one that is attributed for its antimicrobial and antiviral property. The lauric acid content of coconut oil. Next is the sunflower oil. It is used as an adjunct or an additive for coin and safflower oil. It comes from the plant Helianthus annuus. Next is theobroma oil, one of the very most important oils for pharmaceutical industries. Okay? Theobroma oil, ginagamit to siya as a suppository base. Okay? Specifically ang beta form, because beta form of theobroma oil melts at 37 degrees Celsius, or it is the temperature ideal for the body. Okay? While alpha form of theobroma oil has an erratic melting point. Kaya ginagamit ang beta form to be a suppository base or a base for suppositories. Next is we have palm oil. Okay, palm oil, it is widely utilized in culinary purposes or for cooking dishes. It comes from Eliais Gayensine. The soybean oil, one of the widely consumed oil still for culinary purposes or for cooking. Okay? It comes from glycine soya. It is one of the sources of lecithin. Okay, lecithin, isa ito siya sa mga component ng supplements for memory enhancement. Next is rapeseed oil. The commercial form of rapeseed oil is the canola oil, the one that is widely utilized as a cooking oil in households. Okay? The main fatty acid content of rapeseed oil is crucic acid. Okay, so all of those are the different examples of fixed oils. Let's now move to other types of lipids. We have fats. Examples of fats would be lanolin, okay, commonly utilized fat substance. Okay, lanolin coming from Ovis aris and also anhydrous lanolin. Okay, anhydrous lanolin is the dehydrated form of lanolin. Okay, so anhydrous lanolin would contain 0.2% of moisture, while the pure lanolin would contain 20 to 25% moisture. So the anhydrous lanolin is widely utilized as an ointment base, and also it is being added in emulsions. Next is the hydrogenated vegetable oil. Usually, this occurs in solid form as a white powder. Ginagamit ang hydrogenated vegetable oil as a tablet lubricant. Next, waxes. Okay, we have carnauba wax and jojoba oil. Okay, so these waxes are high molecular or products that contains high molecular weight compounds and straight chain fatty acids. Okay, so carnauba wax comes from Copernicia plant. Okay, carnauba wax is used as a tablet polishing agent. Okay, From animals naman, we have spermaceti wax and beeswax. Okay, beeswax comes from Apis mellifera. Okay, basically from Apis mellifera. Ginagamit ang beeswax as a stiffening agent as well as an additive to or excipient to semi-solid preparations like ointments. Okay, carnauba wax comes from Copernicia pruniferum. Jojoba oil comes from Simondicia chinensis. We have the spermaceti wax comes from Pfister macrocephalus organism. Okay, it is commonly used in cold creams. Beeswax comes from Apis mellifera. So there are two types of beeswax. We have the yellow wax, which is used as a stiffening agents in ointments. The white wax naman, it is commonly used in cold creams. Okay? So now let's now move to the another different group of plant compounds, the carbohydrates, which are also classified as primary metabolites. For a moment. Okay, so let's get back. Carbohydrates. These are large group of organic compounds that still contains basically carbon, hydrogen, and oxygen atoms. Okay, but aside from that, they are composed of different functional groups. Okay, so we have the polyhydroxyaldehydes, ketones, alcohols, acids, and other derivatives. Okay, that are being attached to the main structure, to the main carbohydrate structure. Okay, so what are the different classes of carbohydrates? So we have monosaccharides, disaccharides, oligosaccharides, polysaccharides. Okay, so the basic units for carbohydrates are monosaccharides. The disaccharides would contain 2 monosaccharide units. Oligosaccharides would contain 3 to 10 monosaccharide units. Polysaccharides would contain more than 10 monosaccharide units. Again, disaccharides, 2 monosaccharide units. Oligosaccharides, 3 to 10. Polysaccharides, more than 10 monosaccharide units. Okay? So here are the different examples of monosaccharides. So we have dextrose, which comes from Vitis vinifera. Okay? Vitis vinifera. Next is fructose, which is often regarded to be called fruit sugar. Other name ng fructose includes levulose. It is used as a vehicle in some oral dosage forms. Next, xylose. Xylose is also called as wood sugar. Usually, corn cobs are being utilized in order to attain xylose. Xylose is a pentose type of sugar. So, ginagamit si xylose as a diagnostic aid for Crohn's disease. Okay? So, next is galactose. Galactose is a C4 epimer of glucose. Glucose and galactose are epimers at carbon number 4 or under 4th carbon. Okay? So, the disease or the condition is inability to digest galactose is called Gaucher's disease. Next, we have the different examples of disaccharides. Okay, so disaccharides like sucrose. Sucrose contains glucose and fructose units. Okay, so sucrose, its natural sources would include sugar cane, Saccharum officinarum. We have sugar beets, Beta vulgaris, and also sugar maple or Acer saccharum. Okay, so these are the natural sources of sucrose. On the other hand, we have lactose. Okay, lactose is often regarded to be as milk sugar. So it contains glucose and galactose units coming from cows, or its scientific name of cows is Bos taurus. So lactose is widely utilized as a tablet diluent. Okay, once you react lactose with a alkaline reagent like potassium hydroxide, okay, it would form a semi-synthetic sugar called lactulose. Okay, lactulose is usually formed from an alkaline rearrangement of lactose. Okay, so lactulose in syrup form, it is utilized or commonly utilized as a laxative. Next, oligosaccharides. Okay, oligosaccharides would contain 3 to 10 monosaccharide units. One of a common example of an oligosaccharide is malatriose, which contains 3 glucose units. It is also one of the intermediate products of starch hydrolysis. Okay, starch would contain a polysaccharide. Okay, starch contains polysaccharides. In the units of polysaccharides present of starch should be amylose and amylopectin. So mamaya i-discuss ko yun. Another example of an oligosaccharide is dextrine. Okay? So dextrine usually is formed through partial hydrolysis of starch. Okay? We could visibly see dextrine in breads. Okay? Diba ang bread, there is a part that is color brown. That browning part of the bread is called, or it is caused rather, by the compound dextrine. Okay, so we now move on to polysaccharides. For animals, the polysaccharide that would contain from it would be cellulose. For plants, starch. Okay, ginagamit din si starch as a pharmaceutical excipient for tablets and also tablets in oral dosage forms like tablets. Okay, starch would contains 2 units of polysaccharides. We have amylose and amylopectin. Okay, amylose is in linear form. Once that you would subject it to iodine test, amylose produces a dark color. Okay? While on the other hand, amylopectin is branch, which is comprised largely which comprises largely 1 unit of starch. Okay? Okay, so amylose, once it is reacted with Lugol solution or iodine test or iodine reagent, it produces a blue color mixture. While amylopectin, once it is reacted with iodine or Lugol solution, it produces a red or a purple color mixture. Okay, so glycogen is another example of a polysaccharide is more highly branched than amylopectin. For a moment.
Recording stopped.
Kulia gum or locust bean gum as well. These are examples of plant gums. While on the other hand, microbial gums or gums that are produced via microbes would include xanthan and dextran. Okay? So all of these gums would contain specific polysaccharides. Okay? And also another thing, we have mucilages. Okay? So mucilages are metabolic products that would come from plants which contains polysaccharides as well. Okay? So usually plant gums are pathological products that are produced through incision of some plant parts, or there are times that a plant part is being affected, okay, and it would produce plant injury. Okay, usually gums are produced via plant injury. Okay, that's why they are pathologic products of plants. Okay, mucilages, on the other hand, are metabolic products that coming from plants that would also contains polysaccharides. Okay, so next meeting, I'll discuss to you secondary metabolites starting from phenols, okay, up to alkaloids. Do you have any questions or clarifications? By the way, your reviewer or the notes for pharmacognosy was already uploaded, I think, by Ma'am Padilla. So the post-test, instead na ibibigay siya today, it will be given on Saturday. Okay? The post-test, take note, the post-test for pharmacognosy, balestadihan nyo na lahat ng contents na nasa review will be given this Saturday. Okay? February 18. So it will be opened at 6 p.m. Okay? Post-test, Saturday, February 18, 6 p.m. Okay? So please be reminded that at 6 p.m. sharp, you log in directly to your Quipper accounts for the post-test on pharmacognosy. Okay, I think that would be all for this night. I won't hold you long kasi malapit na 9 p.m. din. Any questions or clarifications? Regarding the concern of Miss Kerubin, kindly address that to Ma'am Padilla. Hindi ko siya masagot. I think Ma'am Padilla can answer your query.